Good morning, everybody. So my name is Xavier Marie, and dear colleagues and friends, on behalf of the organizing committee, I wish to welcome you all here in Paris. I'm very happy and excited to open this symposium on 50 years of optical orientation in semiconductors. As you can read in the subtitle, from the original discovery to a new horizon, both an historical perspective and a forward view to the future will be presented during these 2 days. And as Claude Weisbusch will explain in a few minutes, our initial idea for this event was to have a summary of the great physics which was going on in the past 50 years in spin physics in semiconductor, especially triggered by the discovery of Georges Lampel, and also to have a glimpse of the next few years. I don't know if we can speak about next 50 years, but clearly to have also a view on the future. And it's a great honor, and with a lot of emotions, that we welcome Georges Lampel and many renewed scientists to celebrate this 50 years anniversary. And there are about 100 participants today from 12 countries, from US, from Asia, from Europe, and with several generations, as we can see in the room, which attests that how active and dynamic is this field. And with new topics, we will hear about spin-photon interface in quantum dots. We will hear about spin physics in 2D materials. Many great new areas triggered a long time ago, and also many bridges, connection between different fields of solid-state physics, between semiconductors and magnetism, diluted magnetic semiconductors, hybrid ferromagnetic semiconductor structure, great effects which appear in different kinds of material, such as spinel effect, etc. So Georges Lampel is very modest, but he knows how much I admire his pioneering work, published in '68, and the great result he obtained with all this team, with Claude Weisbusch later, Claudine Hermann, many others, Daniel Paget. And so Claude knows that in the past 20 years I have presented many times in conferences his pioneering work, because in some countries people forgot this activity published in '68. It was at a talk in a conference in Asia. We were with Claude that clearly we launched this idea of organizing this symposium celebrating this 50 years. So it's really great to see today so many researchers from all over the world, North America, Europe, Asia, many Russian friends, and we know how strong was the activity, how strong is the activity of our Russian colleagues, both on theory and experiments in this field of spin physics in semiconductors. So probably Georges will recall this as a key characteristic of this work, where he started with not the easiest semiconductor, with silicon and direct gap semiconductor, but in this paper there was all the keywords we found in the past 50 years in many work, not only in bulk, but in quantum wave, in quantum dots, and many other semiconductors, the interaction between light, electron spin, and nuclear spin. So just to finish, I would like to pay tribute to the people who made this conference possible. And first of all, my co-chair, Claude Weisbusch, and all the members of the scientific committee, Thierry Amand, Guillaume Cassabois, Joël Sibert, Jean-Michel Girard, Henri Jaffrès, Olivier Krebs, Michel Leduc, Henri Mariette, Denis Calbert, Daniel Paget, and Jacques Peretti. And I really special thanks to Mélanie Faumont and Jacques Peretti, who did a lot of work solving issues for registration and organization. Many, many thanks to Michel Leduc, who welcome here, who does a lot of work to welcome us in École Normale Supérieure. Thanks to Jean-Marc Berrois, who is the head of the Department of Physics. And to finish, of course, we need some money to organize this. And I'd like to acknowledge our sponsors, CNRS, École Normale Supérieure, École Polytechnique, INSA and different other sources of funding, especially CIRTEC, headed by Michel Leduc, funded by Île-de-France, and different laboratory of excellence. The French Society of Physics, because we heard last week that we obtained a little money from the Société Française de Physique. So I wish you a very nice conference, very fruitful scientific discussion, and my co-chair, Claude, will give a few words on the more scientific aspect of this event. Thank you.
Well, it will not really be scientific, it will be historical. So just a few words of history. First, the place where we are here. Normally we should have been in École Normale, but there was a small problem with room reservation. There was a mistake done over there. So we are here in a very historic place. This is the place where the film archives of France were for at least 50 years, Cinémathèque Française. And all the movie makers, François Truffaut, all the people doing movies came here to see all the movies. It was a fantastic place. You could have Czech movies subtitled in Swedish. So it was really for the people who really wanted to see the movies, okay? This was really a great place. And of course, that's why they kept the architecture. Apparently, when École Normale took over this place, they kept the architecture. So be careful. You cannot go directly from here to your seat, okay? You have to go around. So this is the explanation of this architecture. So let me just give you a few words about the history of discovery, why it happens in Paris, actually. Why did it happen here? It's also because there was a convergence of several efforts. The main effort, of course, was the creation of a lab devoted to spin physics in semiconductors by Lionel Solomon. Lionel Solomon's wife is with us. We are very happy that she's with us. Lionel passed away just a few years ago, very recently. And so it was very strange to have just a full lab devoted just to spin physics in semiconductors. This was not fashionable at all. Nobody basically did spins in semiconductors. You had a few people who had done electron spin resonance in semiconductors before, in the 60s, somewhat in Bell Labs. A lot of efforts were on localized states, on impurities, like on donors in silicon at Bell Labs. But there were very few studies. But here in France, you had both in École Normale Supérieure, the laboratory of Kastler doing spin physics, of course, in atoms, and Claude Cohen-Tanucci will tell us about this. In Saclay, so 20 kilometers southwest of Paris, you had Saclay, where Anatole Abraham had a big laboratory on spin physics in the solid state. Then it was mainly metals that they were studying, and the big emphasis there was polarized targets for nuclear physics, so they have a huge effort on dynamic polarization. And so then it was this critical mass about spin physics, semiconductor, having the idea of polarized light. In the 70s, 60s, 70s, when we started to work, there were no polarizers in semiconductor labs, and there was no polarizer in the group of Solomon. Georges Lampel had to come here to get a polarizer. So it just tells you that this was very strange at that time. And for a few years, when I say few years, it means 15 years, there were only two laboratories in the world doing spin physics in semiconductors. There was the lab in École Polytechnique and the lab in Yoffé Institute, where there are 4 teams, and this story will be told by Slava Safarov a little later. So I just wanted to tell you that for 15 years, spin physics, spintronics, and so on, this was very limited. In the physics of semiconductor conferences, usually you had a split part of the conference, just one session which was half spin, half something else. And every other 4 years, there was an invited paper on spin physics. So things have changed a lot, but we started very, very small. So I would like to thank, in the symposium, we wanted to pay tribute to what had been done in the early times, because people have forgotten, okay, it was a fantastic time. At the same time, everything had to be discovered, okay? So you will see the many discoveries that were made in the early 70s, late 60s, early 70s, both in Paris and in Russia, at the YOOS Institute in Leningrad. And then we'll have more scientific recent work, because of course what is more interesting is what is coming after the discovery. Thank you very much.